Good afternoon, everybody. Let us wait a few minutes to join some other members. All of you mute yourself first. Don't try to create any type of the disturbance. Srinivas sir, Srinivas sir, I hope I'm audible to everyone. Is it right or not? Please respond to anyone chat box.
Sir, it is audible, sir.
Okay, sir. Okay, thank you. Hello, Srinivas sir.
Sir.
Please wait, sir. Please wait.
Okay, sir.
Okay, sir. Sir, may I start my session, sir?
Yes, sir.
Okay. Hello, Srinivas sir.
Sir.
Are you able to see the screen now, sir?
Yes, sir. Creational pattern, sir.
Okay, sir. Okay, thank you. So I start my session now, sir. Is it my voice
Okay, sir.
audible, sir?
Yes, sir. It audible, sir.
Okay, sir. Then thank you, sir. Okay. Good afternoon, everybody. So in the last class, we are discussing about the patterns. So just we try to revise once what we discussed in the last class. So please observe once. In the last class, we are discussing about the patterns. So in that patterns, we are discussing about pattern description, organizing catalogs, and roles in solving designing problems and selection uses. So that means what is a pattern? So what is the purpose of pattern and how we are organizing that pattern? So how we are organizing the catalog and how we are using the pattern to solving the problems and how we are selecting the best pattern and how we are using that selected pattern. So all these topics are we are discussed in the last class. So in this class we try to discuss about the creational patterns. In the last class also I am saying about this. So the patterns are used for to solving the problems efficiently. So in this pattern means nothing but the collection of modules. So in the here which type of pattern we are discussed here. So this is a software architecture pattern. Am I right or not? So that means what is a software architecture pattern? So in the case of software architecture pattern, it consists of set of modules. Okay, it consists of set of modules. These modules are used for to achieve the desired requirements of the users, end users. Am I right or not? Okay. So these patterns are here. We are considering to the three types of ways. So those are, the first one is the creational patterns, and the second one is the structural patterns, and third one is the behavioral patterns. So we are already discussed about all these things. So now we are discussing about the creational patterns. Remaining two types of patterns, that is structural patterns and behavioral patterns. Those are belongs to the fourth and fifth units. Okay, so this is the third unit, and this is the last topic of sorry, this is the second part of the third unit. So in this, here we are studying about the five things mainly. So in the exam point of view also, this is also we are easily guess which questions are maybe asking from this unit. So maybe every unit having the two parts. If you are observed from the first unit onwards, so every unit having the two parts. So maybe in the exam point of view, asking the A and B questions. So maybe A related to the first part of the unit, and B related to the second part of the unit. Okay, so here also third unit having the second part. So that is, please once. Okay, so that is creational patterns. Okay, in this creational patterns we are mainly discussing about the five things. Those are the abstract factory, builder, factory method, and another one is the prototype, and another one is the singleton. Okay, so now we are discussing about the creational patterns. Okay, so creational patterns are used for to creating the objects. Okay, creational patterns main purpose is to creating the patterns. In the last class we are discussing about this. So creational patterns are mainly related with the creating the objects. Okay, not we are running the objects. So that means even though it is a runtime entity, just only here we are creating the object. So in the case of structural patterns, just we try to include which type of things are necessary to forming the object. So in the case of behavioral pattern, so run the object. So that means runtime entity will be considered into the behavioral pattern. Okay, now we are discussing about the creational pattern. What is a creational pattern? In software engineering, creational design patterns are design patterns that deal with the object creation mechanisms, trying to create the objects in a manner suitable to the situation. So that means here the creational patterns are used for to creating the objects according to the situation. So that means here we are developing different types of the architectures. So at this time of situation, it will be developed according to the suitable type of the suitable type of the pattern. Okay, so the basic form of the object creation could result in the design problems or added the complexity to the design. So that means object creation will be used for to solving the problems. So creational design patterns solve this problem by somehow controlling this object creation. Creational design patterns are composed of two dominant ideas. So that means when we are based upon to the creational design patterns, definitely we will consider the two types of design issues. So those are, the one is encapsulating the knowledge about which concrete classes the system use. Another is hiding how instances of these concrete classes are created and combined. So that means, so we are already discussing in the last class. So when the client is requesting the particular thing for to the maybe the software or maybe the end user, then it will be invoking the functionality of the object. So that means whenever object is invoked, so then it will be performing the suitable functionality which is required to the end user. So we already know about this. So that means when we are developing one software to the some particular organization or maybe to the end user, then maybe he is using different types of modules to achieve its functionality. So that means, for example, maybe he is selecting some button, then it will be invokes the action of the object. Am I right or not? So that means he doesn't know which object is invoked and which classes are invoked, how many number of classes are there, and how many number of objects are created. So this information is doesn't know about the user. So that is nothing but abstraction. So that means how much of data is necessary to the user. Only that type of data is provided from the architect or maybe the developer. So here in the case of first idea, one is encapsulating knowledge about which concrete classes the system uses. So that means here we are encapsulating the knowledge in the classes. And another thing is hiding how instances of these concrete classes are created and combined. So that means we try to maintain some hiding. So that means data hiding. So and maybe the encapsulation. So what is the main use of encapsulation? Means nothing but providing the security, and another thing reducing the size also. Okay, creational design patterns are further categorized into the two types of patterns. Those are object creational patterns, and another one is the class creational patterns. So that means the main purpose is the name is implies creational design patterns are used for creating the objects. So now we are considering to the another type of way. So those are two types of ways. Those are object creational patterns, and another is the class creational patterns. So the name is implies object creational patterns are used for creating the objects. Class creational patterns are deals with the class instantiation. Okay, so now we are discussing the main topic is 5 well-known design patterns that are parts creational patterns. So that means when we are consider the creational patterns, definitely we will be consider these 5 parts. So those are, so I'm already mentioned in the syllabus also. So those are abstract factory pattern, factory method pattern, builder pattern, prototype pattern, singleton pattern. Okay, so first of all, we try to see what is the abstract factory pattern. So which provides an interface for creating related or dependent objects without specifying the object concrete class. So that means here we are providing some interface. So that interface is used for to creating the dependent objects, but without specifying the concrete classes. So that means here we need not to specify from which class it will be generating the objects. So just only we are creating objects by using some interface. That type of work will be done into the abstract factory pattern. So in the case of factory method pattern, which allows a class to differ instantiation to subclasses. So that means factory method pattern is used for, it will be providing to generate the subclasses from the class. So builder pattern. So builder pattern means here we are developing different types of patterns, which is separates the construction of complex object from its representation, so that the same construction process can create different types of representation. So in the case of prototype pattern, which specifies the kind of object to create using prototypical instance and creates new objects by cloning this prototype. So that means here we are performing the cloning with the new objects. So that means in some type of situations, maybe we need some other objects to performing different types of functionalities. At this time of situation, we try to cloning with the existing objects. So that is nothing but prototype pattern. And the last one is singleton pattern, which ensures a class only has one instance and provides a global point of access to it. So that means here these are the main important topics when we are consider the creational patterns. So the first one is abstract factory pattern. So in the case of abstract factory pattern, mainly it will be provide some interface for creating the objects without specifying the concrete class. In the case of factory method, it will be provides the subclasses from the existing class. In the case of builder pattern, we are creating different types of representations. In the case of prototype pattern, here we are creating new objects by cloning this prototype. So that means we try to develop the small type of the projects. So another thing is the singleton pattern, which ensures a class has only one instance. So these are the main topics of creational patterns. Now we can see one by one, and we try to identify the concepts of OOAD also, object-oriented analysis design. Okay, so in the previous classes also I'm mentioning about this, and the course outcome of these units. So the students can able to deploy the concepts of object-oriented concepts in the designing patterns. So that means how we are able to design the patterns with the concepts of object-oriented. Okay, so now in normal uses, so the first thing is abstract factory pattern. So abstract factory pattern is a software design pattern that provides a way to encapsulate a group of individual factories that have a common theme. So that means, so what is the main purpose of abstract factory pattern? So able to create the objects by using some interface without specifying the concrete classes. So if you are observed here, the abstract factory pattern is a software design pattern that provides a way to encapsulate a group of individual factories that have a common theme. So these type of factories having the common theme. So in normal usage, the client software creates a concrete implementation of the abstract factory and then uses the generic interfaces to create the concrete objects that are the part of the theme. So that means here we are creating different types of objects, but need not to specify. So where is the occurrence? So that means need not to specify the classes. So just only we are creating the objects, and here we are creating based upon the individual factories. So more than one factories are having the same type of thing. So the client doesn't know which concrete objects it gets from each of these internal factories, since it uses only the generic interfaces of their products. This pattern separates the details of the implementation of set of objects from the general uses. So if you are observed here, so that means client doesn't know about anything. Just he is only using the modules by using some interfaces, but he doesn't know so in which type of it will be performing the actions. Am I right or not? So that means for example, maybe if we are developing some software to the some end users or maybe some organization, so then there is no need to there is no need that type of the engineering knowledge or maybe the coding knowledge should be having the users. So just only we are providing some interfaces. Based upon that interfaces, they are easy, they are maintain the easier interaction with the developed software. So if you are observed here, abstract factory pattern provides an interface to create a family of related objects without explicitly specifying their concrete classes. So that means here we need not specify the classes explicitly. So if you are observing this diagram, if you are observing this diagram, so abstract factory. So this is a actually class diagram. So the first name is the class name, and second thing is here we try to mention the methods. So create product A, create product B. Next it will be divided into the two types of things. So those are concrete factory 1 and concrete factory 2. So create product A, create product B, create product A, create product B. And these are having some association with the some other type of the factories. So that means here we are using more than one. So group of individual factories having the common theme to generate the objects. Okay. But this type of information is not doesn't know about the client. So this is nothing but abstract factory pattern. So if you are observe here, intent. So abstract factory provides an interface to create family of related objects without explicitly specifying their concrete classes. Also known as it is a kit. So that means this is used for to creating the objects. So motivation, modularization is a big issue in today's programming. Programmers are that trying to avoid the idea of adding more code to the existing classes to encapsulate more general information. So that means here how we are creating those objects, and there is no need to providing the additional knowledge for the users. And here when we are considering any type of the topic, here we try to consider the some of the things. So those are the first one is the intent, and second one is the applicability, and third one is the here participants and abstract factory. So these type of things are we should be considered, and collaborations also. So and consequences, and how do we are implementing this. Okay, please wait 1 minute. So that means up to now we are discussing about the abstract factory pattern. In that abstract factory pattern, here we are mainly consider the things are, so we are creating the objects. So if you are observing in the motivation, creating the interface components for different look and feels. So that means here we are creating interface for the for to access the modules, but those type of modules are nothing but to performing the objects functionality. So that means without objects we are not able to run any type of methods or maybe the run any type of the computations. So if you are observe here in the case of abstract factory pattern, so applicability. So we should use abstract factory design pattern when the system needs to be independent of the products it works with or created. The system should be configured to work with multiple families of products. A family of products is designed to be used together, and this is the constraints need to be enforced. A library of products is to be provided, and only their interfaces are revealed, but no their implementation. So that means, so when we are using this, so that means when we are based upon to the library of products, or maybe the group of individual products, or maybe whenever more than one type of factory having the single theme, then we are based upon to the abstract factory pattern. So which type of participants are participated here? The classes that participate in the abstract factory are abstract factory, concrete factory, abstract product, product client. So that means these are the main participants in the abstract factory pattern. So in the case of abstract factory, declares an interface of operations to create abstract products. So what is the abstract? So just only here is specify what we are required. So that means we are hiding some details. Just only we are giving which is required. So in the case of abstract factory, it will be declares an interface. Which type of interfaces are created here? So for to generate the products. Next one is the concrete factory implements the operation concrete products. In the previous diagram also we are observing that number of factories. So that means each and every class having different types of the methods, and those are again divided into the some other subclasses, and those are having some association, and these are having the common theme. Okay, so next abstract product declares an interface for a type of product objects. So next one, product defines a product to be created by corresponding concrete factory, and it implements the abstract product interface. Final one is the client uses the interface declared by the abstract factory and abstract product classes. So that means in the case of abstract factory pattern, mainly we are consider the 5 types of participants. So those are abstract factory, concrete factory, abstract product, product and client. So in the case of abstract factory, declares an interface operations and create an abstract products. Concrete factory implements the operations. Abstract product declares an interface type of the product. Product, so it will be having the association with the abstract product. So final one is the client uses the interfaces declared by the abstract factory and abstract product classes. Okay, so next one is the collaborations. So the concrete factory class creates products object having the particular implementation. To create a different product, the client should be having a different concrete factory. Abstract factory differs the creation of product objects and concrete factory subclasses. So all these are about the concrete abstract factory pattern. So consequences, we are already discussing about all these things. So that means when we are consider one pattern, so we are consider the sum of the things. What are they? So the first one is the problem, and second one is the consequences, collaborations, okay, and participants. So all these are the necessary things in the case of patterns. Okay, so here also we are verifying, so what are the consequences, okay, how we are implementing the how we are solving the problem, and what is a problem, okay, and identifying the and identifying the participants, and identifying the applicability. So all these things are here we are discussing about the abstract factory pattern. Okay, so in the case of abstract factory pattern, consequences are it isolates concrete classes, it makes exchanging product families, it creates consistency among the products, supporting new kinds of products is difficult. So that means here up to now we are discussing about the first part of the creational pattern. So that is abstract factory pattern. So the main purpose of using the abstract factory pattern is generating the objects by providing some interfaces without explicitly mention the classes, concrete classes. So for this purpose here, which type of collaborations are used, how many number of participants are there, and what is the applicability when we are used. So and if we are using this, then what will be the situation. So all these things are now we are discussing. So the second one is the factory method pattern. Okay, this is an object-oriented design pattern to implement the concept of factories. I think the name is implies factory. So what is the meaning of factory? It will be able to generate something. So that means we are, when we are in the case of implementation. So in the case of first case, but we are not implementing anything, just we are having some design. So it is a abstract, it is a abstract factory pattern. So okay, so just only it will be having some abstract too. So what to be we are generated. So but we are not, need not consider the classes. But in the case of factory method pattern, here we are implementing the design patterns. So this is an object-oriented design pattern to implement the concepts of factories. Like other creational patterns, it deals with the problem of creating objects without specifying the exact class of object that will be created. So that means here we are directly creating the object without specifying the exact class. The essence of the factory method pattern is to define an interface for creating an object, but lets the classes that implement the interface decide which class to instantiate. The factory method lets class differ instantiation to subclasses. So that means, so we are already discussing about this thing. So in the case of first case, here we are mentioned the five parts, five parts of the creational patterns. So those are, the first one is abstract factory pattern, factory method pattern, builder pattern, prototype pattern, singleton pattern. In the case of abstract pattern, so how we are creating the objects without specifying the concrete class. In the case of factory method pattern, here we are allowed to generate the subclasses. So nothing but here we are differentiation to subclasses. Okay, so here now we are discussing about the factory pattern. Okay, factory method pattern. Okay, so if you are observing here, defines an interface for creating an object, but lets subclasses decide which classes to instantiate. Factory method lets a class differ instantiation to subclasses. So that means here we are implementing the procedure to creating the objects, and we are able to allowing the subclasses, and we try to provide the some instantiation. So which class is able to connect with the which type of object. So that type of the things are here we have specified. If we are observing this diagram, product, so concrete product, so that will be related to the concrete creator. Okay, please wait. Okay, thank you. If you are observing this diagram, the first one is defines an interface for creating an object, but lets subclasses decide which class to instantiate. So that means here we are creating an object. At the same time, we are allowing the subclasses also. So if you are observe here, creator, concrete creator. So concrete creator is the subclass. At the same time, subclass can be using the main class of the method, factory method. So we also know about this inheritance. Okay. Next one is the motivation, document and application. So which type of operations are used? So in the case of factory method pattern, so open, close, save, revert. So application, so create document, new document, open document. So my application. So which type of operations are used, which type of methods are used, and how many number of subclasses are there. So all these things are mentioned in the case of factory method pattern. So applicability. So applicability, when we are using this, a class can't anticipate the class of objects it must create. A class wants its subclasses to specify the objects it creates. Classes delegate the responsibility to one of the several helper subclasses. So that means we are based upon the subclasses, and we are providing the instantiation with the class subclasses also. Okay, and another is the participants. So here we are consider the four types of participants here. So product, concrete product, creator, concrete creator. So defines the interface objects of the factory methods creates. So that means here we are defines the interface of the objects the factory method creates. So that means whatever it may be, we are creating the interfaces, and whatever it may be, we are creating the objects. Those are defined in the case of product. So in the case of concrete product, implement the product interface. So how we are implementing the operations of the creating the product. So creator declares the factory method which returns object of the type of product. So concrete creator overrides the factory method to return the instance of the concrete product. So you don't try to, this topic is very hard to understand. Why? Because why I'm explaining like this, just I'm including the concepts of OAD here. Okay, you don't try to feel about this, just you try to we try to remember what is the exact topic. So what is the exact topic? Factory method patterns are used for implementing the operations of to create to generating the objects. Okay, but here we are allowing the subclasses. So that is the main thing. Okay, don't worry about to this. So next one, collaboration. Creator relies on the subclasses to provide the implementation for the factory method so that it returns an instance of the appropriate concrete product class. Okay, next one, consequences. The main reason for which the factory pattern is used is that introduce a separation between application and family of classes. So that means here we are providing some differentiation from the class to the subclass, and here we are providing some instantiation with the subclasses. Okay. Next one is the builder pattern. So what is the purpose of builder pattern? So able to generate the more than one representation. So this is an object creation software design pattern. The intention is to abstract steps of construction of objects so that different implementations of these steps can construct different representations of objects. Often the builder pattern is used to build the products in accordance with the composite pattern. So that means here we are able to present the different types of representations of the objects. So that is the main use of builder pattern. So that means up to now we are discussing about the three types of patterns. One is the abstract factory pattern, factory method pattern. So next one is the builder pattern. Okay. So in the case of abstract method pattern, so in that one here only we are declaring the objects without specifying their classes. In the case of factory method pattern, we are creating the objects without specifying their exact class, but allowing the subclasses to providing the instantiation. Okay, so next one is the builder pattern. So this is used for intention of this one is used for constructing the different representations of the objects. Okay, if you are observed here, the intention is to abstract steps of construction of objects so that different implementations of these steps can construct different representations of objects. So you don't feel about these topics, just only you try to assume how we are constructing the building. So how we are constructing the building? First of all, we are try to gather whatever it may be required to constructing the house. Am I right or not? So at the same time, here we are verifying some type of feasible study, whether it will be able to develop within time, how many number of workers are needed, how much of time is needed, how much of money is needed. So like this. So at the same time, we are based upon to the some design. So when we are creating that one, so just we are based upon to the different types of the things. So in that way, here also, when we are developing some software, first of all, we try to gather what we are maybe required, and based upon to the some design. Now, next we are implementing the software. So we also know about this. Next, we are performing the testing, and next releasing the that software to the end users or maybe the organization. Okay, next find out the errors. If any errors are there, then we try to recorrect it. Okay, so this is the development of software cycle. So actually we are when we are developing some software, we are follows the same types of the steps. So what we are discussing now, so how we are creating the patterns. So that means how we are, what are the steps, which type of steps are needed. So when we are based upon to the patterns, so nothing but the collection of modules. So how we are creating those type of patterns. So that means here these are the behind the topics, or maybe these are the hiding topics in front of the clients. So they doesn't know how the operations are performed. Just they are able to click the button and able to see the output, but they doesn't know in which type of way invoking the objects and able to choose the functionality. Am I right or not? So in the same way here, so in the case of creational patterns, we are consider the some parts. So those are the abstract factory pattern, factory method pattern, builder pattern. Okay, and next one is the singleton pattern. And in this type of we are consider different types of patterns here. So in each and every pattern, we are achieving some functionality of the modules through generating the objects for providing the interfaces. So that means they are just only interacted with the interface. So they are not having any type of the programming knowledge. So in the case of builder pattern, so main intention is able to construct the different types of representations. Okay. Often the builder pattern is used to build the products accordance with the composite pattern. Please excuse me once. Excuse me once. Okay, thank you. So if you are observed here, separate the construction of complex object from its representation, so that the same construction of process can create different types of representation. So that means here we are performing the decomposing. So that means avoiding the complex design. Just only we are based upon the different types of representations of the same thing. So separate the construction of complex object from its representation, so that the same construction process can create different types of representations. If we are observing this director construct, so that is the main method of director. So then it will be associated with builder. So next it will be association with the concrete builder. So builder, concrete builder. So that means, so next one able to generate the product. So in the case of builder pattern, so in the case of builder pattern, mainly consider these four participants. Okay. Okay. Next. So non-software example. For example, if it is a non-software. Okay. If you are observed here, so customer, cashier, restaurant. So for example, maybe if we are considering like this, so here we are consider one example also. So that is order kids meal. So we also know about this in the case of sequence diagrams. So sequence diagrams here, first of all, order the kids meal. Next, build that meal. Next, build that. Next, finally, get the meal from the restaurant. And finally, we are paying the amount for whatever it may be we are ordering the food. Am I right or not? So that means these are the sequence of steps. So that means here also we try to assume the same thing. In the place of customer, you try to place the client. So in the place of cashier, you place the director. So in the case of restaurant, so here we are considered some builder. So that means builder able to build the thing, director regulate the thing, and client able to receive the data from the builder through director. Okay. So this is the non-software example actually. Okay. So motivation. So you try to mention these type of the things. So intent, motivation, collaboration, participants, applicability. So you try to mention all these things for every type of the pattern. So that means when we are used, so which type of things are collaborated, so how many number of participants are there, so what is the main intention of this pattern. So these type of things are we try to mention to giving a better representation. So motivation. So for example, maybe if we are using this, so in which type of we are creating the environment. For example, maybe if you are creating some house, then what is our motivation? We try to collect whatever it may be, require the things. So we try to collect whatever it may be the things are required to constructing the house. So that is the first step of motivation. So that means we are ready. Then which type of things are necessary, that will be identified in the case of motivation. Am I right or not? So in the same way here also, in the case of builder pattern, also, here we are based upon to the some motivation. So which type of things are needed? So that means builder is needed, concrete builder is needed, product is needed, okay, director is needed. Okay. Okay, applicability. So when we are using the builder pattern, so use the builder pattern when the algorithm for creating a complex object should be independent of the parts that make up the object and how they are assembled. So we also know about this. So that means when we are creating a largest module, so then we try to dividing into the sub modules. For example, maybe we are searching for some student. So then we are not going for to the exact student. So when we are searching that student, it will be giving some options: first year, second year, third year, fourth year. For example, maybe if there is the no option for giving the roll number, then we try to search through name. Am I right or not? So that means, so at this time of situation, so more the same name for assigned to the more than one person. So at this time of situation, we are not easily find out that particular person. So here we are based upon the some subclasses. For example, when we are search for some student, so it will be giving some options. So first year, second year, third year, fourth year. So next we are selecting that student. So maybe so that student related to the first sem or maybe the second sem. So in which sem you are try to search that student. So in some type of situation, some of the students not participated into the every sem. So some of the students know about this reason. Why? Because they may be having the backlogs. So according to the university rules, some of the students are not able to promote into the some other sem. So maybe that student is in the first sem. At the same time, that's the same student is not able to present in the second sem because of if that student is having the backlogs. So here we are giving some sub modules. So in the case of first case, search for the student. First of all, giving the first year, second year, third year, fourth year. So next we are selecting that the year. Next we will giving the option first sem or second sem. So in the same way, here also we are providing some subtype of the subclasses. Okay, so when we are dividing and designing the complex thing, then based upon to the subparts, the construction process representations for the object that is constructed. So that means here we are providing different types of representations. Okay, next participants. So in the diagram also we are observing that thing. Builder is used for to building that. So software, concrete builder, next director, next product. So which is formed by the builder. So that will be referred as a product here. And as a subclass for the builder is concrete builder, and director is regulating the builder. So if you observe here, builder provides an abstract interface for creating parts of the product object. So next, concrete builder constructs the assembles the parts of the product by implementing the builder interface. So that means whatever it may be, creating the interface that will be assembled by using the concrete builder. So in the case of builder, provides an abstract interface. In the case of director, constructs an object using builder interface. Product, whatever it may be, the ready. So which is ready by the builder. So that it will be referred as a product. Here represents the complex object under the construction. Okay, consequences. So that means what are the results? So the benefits and the pitfalls of builder pattern are: it lets you vary the product's internal representation. It isolates code for construction and representation. It gives you finer control over the construction process. So that means design is easy, and here we are able to identify the internal position, and we try to provide the some isolation. Okay, so next one is the prototype pattern. This is the creational design pattern used in software development when the types of objects to create determined by the prototypical instance, which is cloned to the produce new objects. So that means we are creating some objects. Now we are mixed with the some other new objects. So that type of thing will be done into the prototype pattern. And in the other case, in some type of situations, before developing the actual thing, we try to based upon to the small models. If the small model is success, then we go for to the actual thing. So that type of the pattern is also nothing but prototype pattern. So that means we try to implement it by using in the small types of steps. So that is nothing but prototype pattern here. So this pattern is used to avoid subclasses of an object creator in the client application, like the abstract factory pattern does. So that means here we are using actually factory pattern. So abstract factory pattern. So that what is the purpose of abstract factory pattern? So it will be able to creating the objects without specifying their concrete classes. So those type of steps are avoided if we are based upon the prototype pattern. Avoid the inherent cost of creating new object in the standard way. For example, using the new keyword when it is prohibitively expensive for a given application. So that means it will be reducing the cost and able to identifying the feasible study and able to creating the objects and able to performing the cloning with the existing objects. So that means able to generating the new objects with the cloning. So next one is the prototype pattern. So to specify the kinds of objects to create prototype instance and create new objects by copying this prototype. So that means here we are copying some new objects with the existing one. Then able to we are generating some new objects. So if you are observe here, so client prototype, concrete prototype, and finally we are generating the some product. Okay. So prototype pattern like this. Next participants, client to prototype, client prototype. So client purpose is creates new object by asking prototype to clone itself. So that means whenever client is asking about the prototype, then it will be performing the cloning. Prototype declares an interface for cloning itself. Concrete prototype implements the operation of cloning itself. Okay. These are the, for example, these are the object-oriented analysis design models. Next, final one is the singleton pattern. So this is a design pattern that restricts the instantiation of class to one object. This is useful when exactly one object is needed to coordinate actions across the system. So that means the name is implies here we are uh, assigning the one object to the one class. Okay, the concept is in sometimes generalized to systems that operate more effectively when only one object exists or that restrict the instantiation to certain number of objects. The term comes from the mathematical concept of singleton, to create exactly one object of a class and to provide global point of access to it. So that means only one object from the one class, and that one object will be access the all operations in a single class. That is nothing but singleton. Non-software example, for example, so uh, this is a non-software example. If you are in the case of motivation, so need to create exactly one user interface object, need to create only one print spooler. So that means this is about the motivation. So I am already saying about this, when we are specifying some particular pattern, you need to mention the some of the things. So those are motivation, intent, and applicability. Okay, and collaboration, applicants, like this. Okay, applicability, singleton pattern. So when we are using this, there must be exactly one instance of a class to provide a global point access to it. When the sole instance should be extensible by subclassing, then clients should be able to use the extended instance without modifying its code. So participants, static data member, private constructor, a static public method returns reference the static data member. Collaboration, client access the singleton instance solely through the singleton's class operation. So consequences, what are the results? So controlled access to the sole instance, reduced namespace, permits refinement operations and representation, permits a variable number of instances. So that means easily we are creating the objects. Okay. So that means up to now we are discussing about the different types of patterns in the creational patterns. So those are the first one, abstract factory method pattern. Second one is the factory method pattern. Third one is the builder pattern. The fourth one is the prototype pattern, and the last one is singleton pattern. Okay, if you are revising these things, so the main purpose of using the creational patterns are used for creating the objects. Okay, so just only these are used for to creating the patterns. Okay, so that means in this unit, just only we are discussing about what is a factory, abstract factory pattern, and factory method pattern. Okay, so what is the abstract factory method pattern? Provides an interface for creating related dependent objects without specifying the concrete classes. So that means able to creating the objects but without specifying their concrete classes explicitly. Factory method pattern allows to generate the subclasses. So builder pattern able to generate the different types of representations. So prototype pattern, cloning, performing the cloning with the new objects. Singleton pattern able to accessing the only one object with the only one class. So this type of patterns are used into the creational patterns. So today we are ending the topics of total topics of third unit. So in the next class we try to revise what we discussed up to now in the third unit, and this is the syllabus for first mid. You try to prepare for the first mid, and if you having any type of the doubts, you please ask me. If you not understand about these topics, you don't worry. So just I'm including some of the topics of the OVAD here. So that's why I'm if you're having any type of the confusion, you don't worry about this. So I will try to revise the class tomorrow. So then if you're having any type of the doubts also, I'm giving the some time to clear the doubts. So if you want to clear your doubts personally, please contact me personally. Okay, if you're having any type of the attendance issues, please contact the Srinivas sir. Thank you Ananda. Srinivas sir, may I end the session sir?
Uh,
Thank you, sir. Thank you.
Okay, sir.